Hey folks, so in this video I want to talk about device management system calls. Now I know the last video on file management was a little bit short, and you're going to see why in this video, because we're going to talk, because somehow, right, there's this idea that a storage device is really just, well, it's a device, it's already in the name, right? It's a hard drive, but it's still a storage device. All right, so the idea of a device is just something connected to your computer. Maybe that typically has some sort of a memory, because without memory you can't really do anything. So it could be a hard drive, it could be a video card, it could be all sorts of things. So how do we interact with them, right? A device is very abstract. Somehow maybe the only thing there we have, right, is this idea that they all have memory, okay? And your devices, right, can be all sorts of things. They can be physical things, they can be virtual things, it can be whatever, okay? How do we deal with it, right? How do we deal with something that's so, not very concrete? Well, there are going to be three operations: read, write, and reposition. And my claim to you guys is that this is actually enough to do anything. Now think about that for 1 second. How could so let's say here, right, that I have the ability to write a bit, read a bit, and then reposition, right, change like where I'm at. How can that be enough? Is that enough to deal with any sort of device? Think about that for 1 second. So I don't know what conclusion you came to, but at least for me, I think that you can do a whole lot of things with read, write, and reposition, and probably you can do pretty much anything. So how? Let's look at a specific example. So let's talk about graphics cards and how they used to work on legacy systems. So read, write, and reposition don't seem to do a whole lot at a glance, right? So read a byte, write a byte, reposition where I'm reading and writing from. Doesn't seem like it's a whole lot. Okay, so let's think about system memory. By default, there's some sort of memory that's allocated to the system, right? And it could be, some amount, right? That's physical RAM chips in your computer. And that has some sort of address space. What are all the valid addresses that are there? So let's say they start at 00 and they go up until, I don't know, let's say 1F, right? So you have some physical memory, right? And it's normally, right, supposed to be much larger numbers. It could be a whole lot of memory. What I can think about doing is the following: is I can say that my lower memory ranges correspond to my physical RAM, and then my higher memory ranges, so let's say 1F to, I don't know, 2F, right, this stuff over here, this actually corresponds to a device, right? So my device has some memory on it. What I can basically say is, oh, when a program wants to use a specific address that's above some threshold, right, above 1F here, instead of changing RAM, it'll change the memory in the device, right? So this is an interesting idea, right? This is the idea of memory mapping, right? So here, right, this could be our RAM, main system RAM, and this is on the motherboard. I'll just do this MB here, versus this is your graphics card. The graphics card has its own RAM, which we'll call VRAM, or video RAM. And so what we'll say is the following: when a program makes it, so let's say I have a program running. My program normally, right, wants to do things like write to memory. If it writes to certain memory ranges, it changes RAM. All's good. If it writes to memory above a certain point, it'll go up here. Okay? So all of a sudden I have basically a way to access my external device, right? So I'm basically saying this device has some memory, and I'm going to basically concatenate that memory with my normal RAM memory, right? And all of a sudden my program can basically access it. So for example, if I do a poke at, say, I don't know, at 0x1f, I could maybe poke in FF000, and this is, you can imagine this is RGB. I'm putting the color red into my memory, right? So I have basically my graphics card has this memory range over here that's reserved, and somehow, right, that's really my screen, right? So I have my screen, and my screen looks like an array, a 2D array, and these different little pixels here, right, basically correspond to a different location. So my first pixel, right, is 1F. My next pixel is 20. My next pixel is 21. Next pixel is 22. Next pixel is 23. Next pixel is 24. Right? So my different pixels up on my monitor, right, that are really, my monitor, right, is basically representing the stuff that my graphics card knows. Those different pixel values there, right, are all basically different addresses in my overall memory, right? So if I do a write to 1F, I'm basically setting this first pixel to red, right? If I poke, say 02, and I do 00FF00, well, that should be green. So I would basically be making this pixel green, right, versus this first one is red. right? So I basically, you can picture, right, my video memory is this huge array, and I'm just setting things into it, right? I'm setting this value here, and that corresponds to changing this pixel on my screen to this particular color, okay? And so this is actually how they implemented graphics in the good old days, right? Is that you basically had to have all these different commands to set these special values into this region of memory, and that would correspond to changes on your screen, okay? And so this is basically a way to use an external device, right? So my way that I communicate with my external device, right, my very generic way, right, and this can be used for basically for anything, is to have it basically concatenated as a region of my memory, and then my program can go and edit that part of memory, and that part of memory basically will be visible to my device, and my device will do different things, right? So when I poke here, my device knows that that means change this pixel to green, change this pixel to red, and so on, right? And so this is a very typical thing to do, right? Is basically have this notion of memory mapping, where if I have a device I don't really know like how to interact with it, what I basically do is I reserve some memory for it and say, okay, I'm going to basically map any calls my program makes to this memory to be actually changes to you, right? So I'll go and change your memory, right? And this gives us kind of a very, very generic way to interact with external devices. All right, so in this video, right, we talked a little bit about basically device management. Overall, what I want you guys to think about is the idea of read, write, and reposition, and how they can basically be used to interact with any other device by having this memory map concept of taking memory that a device has, map it to main RAM, that memory programs can talk to it indirectly.